Okay, continuing on here in 7.7 with composition of functions. We just got done looking at when the two functions were given as relations. And again, the key is you got to work right to left. Okay, and so just remember that composition of functions, we're working right to left. Okay, now we're going to look at when the functions are not relations, they're given as expressions in terms of a variable, in most cases x, but could be a different variable. Okay, we want to look at that, and then what's going to output is another function, basically. Okay, so this first one, we've got find f of g. Oops, sorry about that. Let's undo that. Okay, find f of g of x and g of f of x. So we're going to do f of g of x. We're going to do both of them given these two functions right here. So let's do f of g first. This means start with g, then f. We're working right to left. So I start with g and then go to f. So this really means f of g of x. So this means start with g, go into f. So what this means is plug g into f. So I want to do f of g of x is 2x minus 1. So what does that mean? Now, I want to write down what function f is. F is 3x squared minus x and plus 4. What this really means, and you got to really follow this closely, is if I'm doing this, I want to plug that in for x in function f. Here's what I mean. Now it's kind of like substitution, but you're plugging an expression with the same variable in for that variable in the other function, and that's why it's sometimes a little hard to follow. So here's what it means. Every place I see an x in function f here, I want to put in 2x minus 1. So here's what it means. I have this 3. Now, where I have this x right here, I have to put in 2x minus 1. So I have 2x minus 1 in parentheses, and I want to square it. Now, I also have an x right here, so I want to take off. Now, in for that x, I want to put 2x minus 1. So, more than one term, put it in parentheses, and plus 4. And now you just simplify the expression. Here's going to be the key part, though. I've got 2x minus 1. So I have 3 times. What do I get when I take 2x minus 1 and square it? Well, if you remember a binomial squared, you got to write it out twice like this. And we got to say, okay, FOIL it. So 4x squared. Outside terms would be minus 2x. Inside terms, minus 2x. Last terms would be plus 1. So it would be 4x squared minus 4x plus 1. So there's what I got when I FOILed it together. So that's this part right here. Now we're going to have to multiply that by 3, which then means I'm going to, in my next step, have to distribute the 3. So let me just write the rest of the expression as we have it here. Okay, so this means square that binomial. Now to multiply 3 times that, I distribute my 3, so it's 12x squared minus 12x plus 3. Distribute your opposite sign, so it's minus 2x plus 1 plus 4. And now we combine like terms. I only have one x squared term, so I took care of that. Minus 12x minus 2x is minus 14x. So took care of those. And then we have plus 3, plus 1, and plus 4. So if I add those together, it's plus 8. So there is f of g of x. That means plug g into f. Now we want to find g of f, and I have that on my next screen. But now when I do g of f, now I want to start with f and plug it into g. So plug function f into g. So plug f into g. So I want to find g of f of x. So I really want to do g of, now, what's f of x right here? Well, f of x is 3x squared minus x plus 4. So that means, and I'm going to write down the function g of x here. Remember, g of x is this function, 2x minus 1. So that means every place I see an x in function g, I want to put in the expression 3x squared minus x plus 4. So here's what we have, 2. Now I have an x right here. In for that x, I'm going to put 3x squared minus x plus 4. Because that's going in for x in function g. Well, and then I have the minus 1 here. Now, how do I simplify this? I distribute, so it's 6x squared minus 2x plus 8 minus 1. Combine like terms, so I can just combine my constants here, which is plus 7. So it's 6x squared minus 2x plus 7. So you really have to be organized and kind of know, work right to left, plug it in, and it's substitution basically, except for you're plugging the same variable in for the other one. Okay, and then simplifying the expression. Now for part B, we want to really find it when x is negative 2. So I want to do f of g of x and g of f of x, except for x is negative 2 means we're going to have negative 2 in these two spots. So I'm going to do f of g of negative 2. That really means, get you familiar, f of g of negative 2. Now, when they give you a value instead of the, now they are giving us the expression, but they're really telling us this. This means I really want to plug, you want to work right to left again. But now, when this is a number right here, in this spot, that means I want to plug negative 2 into g, and then whatever that outputs, I want to plug that into f. So here's what I mean. I'm going to plug negative 2, I'm going to start with g, and I'm going to plug negative 2 in. So g of x is 2x minus 1. So I want to find g of negative 2. So I plug negative 2 right in here. So it's 2 times negative 2, subtract 1, negative 4, subtract 1, and that outputted negative 5. Now I take negative 5, and I'm going to plug that. I did negative 2 into g. Now this, so I'm really finding then f of negative 5. Well, f of x is 3x squared minus x plus 4. So if I do this, I'm finding f of negative 5. Well, now I put negative 5 in here, there, and there. So I'm putting it in for x in these two spots right here. This is, now I got to do the square first, so this is 3 times 25 minus negative 5 plus 4, so 75, and this turns into plus 5 because of that, plus 4, 80 plus 4, which is 84. So basically, f of g of negative 2 outputted 84, and that would be your answer. If I go the other way, and I find now g of f of x, so now I want to do g of f of negative 2, which really means g of f of negative 2. So I'm going to work right to left. Negative 2 into f, whatever that outputs, into g. So we're going to start with f. So f of x, if we remember, was 3x squared minus x plus 4. So I'm really putting negative 2 in for x. So let's figure that out. If I put negative 2 in, it's 3 times negative 2 squared minus negative 2 plus 4. So this is 4 when I square negative 2. So 12 plus 2 plus 4, 14, so that's 18. Now I take 18. Okay, now I take 18 right here, and I'm going to plug that into G. So I'm really finding G of 18 then. So G of x, if we remember, G of x was just 2x minus 1, a fairly simple expression. So now I'm finding G of 18, which means I want to plug 18 in for x. So it's 2 times 18 minus 1. 2 times 18 is 36. 36 minus 1 is 35. So when I do G of f of negative 2, my final output is 35. I put negative 2 into f. Whatever that outputted went into G, and there's my final answer, composition of functions. Okay, a fairly long lesson, but you have to be very organized to understand composition of functions.